Wireless network security. So while our wireless networks give us a lot of convenience and give us a lot of great operational ability, they are not inherently secure. Because again, we don't have cables that we're plugging in, it's just signals going through the air. And so anybody can snatch those signals out of the air and listen to them, right? So we have to make sure we have the correct placement of our wireless access points to ensure that it's secure inside our building. We don't want it leaking out of our building and into the parking lots, for instance. And we have to encrypt our data to make sure that the data we're transferring is secure, because if it's unencrypted, anyone can read it. If it's encrypted, it's all scrambled and jumbled. They won't be able to read it. So where do you want to place your access point? Well, if you're using ESS, that extended server set, where you're using multiple access points together, you have to make sure those access points aren't going to conflict with each other. So again, we have that 1, 6, and 11 for the channels. In this example here, I would probably have 1 here, 6 and 11 here, and then make this one 1 again, because I wouldn't want the 1 touching a 1. Because if I do, they're going to have interference between each other. Your coverage needs to overlap some, so as the person is walking through the zones, they're not dropping signal. If you've ever been driving across country with your cell phone, you're hoping they have good overlap everywhere you're going. Otherwise, you're driving and you drop calls, right? Same concept with our wireless networks. We want to be able to have uninterrupted roaming from one cell to another. But overlapping coverage areas should not use overlapping frequencies. So again, I don't want 1 to touch 1. I don't want 6 to touch 6 or 11 to touch 11. And so when you see that, you have something like this. And so if I have 3, I have 1 is touching 6, 6 is touching 11, and 11 is touching 1. All those are different channels. If you go further, we create this honeycomb effect. You'll notice that none of them are touching each other, right? There's no double numbers touching each other. That's what we're aiming for. By having no overlapping coverage here, a non-overlapping coverage cells for the 2.4 spectrum, we always are aiming for 10 to 15% overlap. That way, as we're getting further from the access point and the signal starts dropping, we're picking up the next access point before we drop completely. That's why we have that little overlap gap between the two. And again, we want to make sure that we are not touching the same numbers, otherwise we can drop. For the A+ exam, this idea of overlapping cells is not covered on the actual exam. If you go into Network Plus, this is a concept that they're going to test you on. For A+, you're not going to be tested on it, but from troubleshooting networks, this is going to become very crucial to you as you're testing it, right? You go and work on somebody's office, and they've got a single access point all the way in the far corner of the building, and they can't understand why the CEO's office on the other side of the building doesn't have wireless access. It's all about distance and reach of these access points. So in that case, you may need to set up an extended server set and put one access point on either side of the building, right? So improperly installed access points are a huge security vulnerability for your business. You gotta think about it like this. If you put an Ethernet port in your building's parking lot, anyone can drive up and plug into your network. Same thing with wireless. If your signals are going outside your building, outside the area you have control, somebody can pick it up. 2 terms that are associated with this. One is called war driving. That would be like me and Chuck get in the car, and Chuck starts driving around, I'm saying in the passenger seat, and I'm seeing, where can I pick up wireless signals? And I start mapping out, okay, as I'm driving across the county, there's a signal here, and there's a signal there, and I found one at 123 Main Street, and 456, Sandova Avenue, or wherever it happens to be, right? Now if I'm gonna go do some malicious, nasty stuff on the internet that I don't want to get caught doing, I'm gonna go do it from your house that was left open, and not my house. That way when the FBI comes looking for that hacker, they're going back to Sarah's house and not Jason's house, right? So that's the idea of war driving, is figure out where these access points are that are open that we can use. Often, I will tell you in the real world, I haven't seen war chalking done in probably 10 or 15 years. It's all gone digital at this point, but they still cover it in the textbook all the time. War chalking essentially is when a user will write a symbol on the wall, then notifies other people of what they found when doing their war driving. So I drove around and I found that 123 Main Street had an open access point. I might draw that open node symbol and write down the SID of, family name here, and the bandwidth of, it was a 3 gigabit per second connection. Because they might be running, wireless AC or something. So those are the kind of things that war chalking does. It's just telling other hackers what you found when they walk by. Now, are you going to see this on poles outside buildings and stuff? Not usually. Now, most of this is done on websites. So wireless threats. The 2 big threats that we're going to talk about here is WEP and WPA security cracking. WEP and WPA we'll talk about more in a second, but they are the original forms. WEP was first and WPA was second of doing encryption of our wireless networks. And as we talked about a little bit earlier, if you have an insecure password or an insecure algorithm, we can crack that and get on your network even though you have encryption, okay? If you're using WPA or WEP, both of those have flaws in them. They have been cracked. No matter what your password is, someone's going to get in your network. Don't use WEP, don't use WPA. You should be using WPA too. There are utilities out there that capture these wireless packets. They run them against a mathematical formula, and they can determine what the key is, what your password is, because it's a weak algorithm. A rogue access point. What a rogue access point is, it allows a malicious user to set up their own access point to lure you guys, the legitimate users, to connecting to it. This might be me sitting in the back of Starbucks, setting up my laptop, which is connected to the internet, and I send out a beacon that says, hey, connect to Starbucks Wi-Fi here. So you're looking for free Wi-Fi and you connect to me, not to Starbucks. Okay? Now everything you're doing is going through me. I can capture all your traffic and I can look at it all, right? This is very common in airports because travelers are stuck there for a couple of hours and they're all looking for free Wi-Fi. You could set this up very easily and start capturing everybody's data because most people are dumb and will connect to free Wi-Fi without even thinking about it, okay? Best thing to do is have a cellular modem and use a cellular modem. Use your cell phone. It's got a cellular modem in it already, right? Use that to get online. Don't connect to free Wi-Fi you don't trust, okay? MAC address filtering. So we talked about that every network device has its own unique MAC address, and we can use that as a way of securing our networks. So we can actually configure our access point with basically a bouncer list, if you want to think of it this way. We have a list of all the people that we say are okay, based on their MAC address. And so when you try to connect, Chuck tries to connect, it goes, oh, Chuck, he's on the list. He can be let in. Nick's on the list. He can be let in. Joe's not on the list. Don't let him in, based on their MAC address. Okay. So you can do this one of two ways. You can either do explicit allow, where you only allow the people on your list, or you can do explicit deny, which is allow everybody but the guy I don't like, right? Yes, exactly. Blacklist versus whitelist, right? Whitelist is I allow you 6 people because you're in my class. Blacklist is I don't allow you 6 people because you're in my class, right? So it depends on how you want to look at it. The problem with MAC address filtering is if you're a knowledgeable user, you can change your MAC address with some software very easily. It takes about 3 seconds, maybe 5 if you're a slow typer. So changing it is very easy. So blacklisting doesn't work very well because I'll give you an example. You go to a hotel and a lot of the fancy hotels will charge you $10 a night or $15 a night for internet access, right? Most of them will give you 10 minutes free. And so what ends up happening is you get online and you get 10 minutes for free. And after that it goes, sorry, you need to pay for the extra hour, or you pay by the hour, pay by the night. But if you change your MAC address, they'll give you another 10 minutes of free because that's how they're doing it. They're using a blacklist. And so every 10 minutes you change your MAC address, you get free internet all night, right? So blacklists aren't very effective. And again, you can use things like Mac Changer or Mac Daddy X. They're a graphical program and it will change your Mac over and over and over again. We do this all the time in penetration testing exercises, okay? Whitelisting is a lot more effective because for me to get in, I have to know somebody who's on the whitelist. Kind of like stealing their ID. Again, not real challenging to do for somebody who knows what they're doing, but it will stop most people from getting into your network. It's not good on its own, but it is a good thing to use. Disabling the SSID broadcast. So when you go to your computer and you try to connect to a wireless network, and you click on the little wireless icon, you get a list of all the access points in the area, right? So if I go right now, I would see one for AACC and I'd see one for the Green Turtle and one for Subway, etc., right? That's called the SSID, that name, server set identifier. And so in this case, the picture, my ID name is Teddy Bear. Okay. If I right now went out there and looked for Teddy Bear, you'd find a Teddy Bear one, right? But if you disable the broadcast, it won't go out and say, hey, I'm Teddy Bear, connect to me. It'll be there, but it's hidden. And so for you to connect to Teddy Bear, you'd have to know that was my network's name. Okay. So in business, we usually put out our name there, right? Panera free Wi-Fi, Starbucks free Wi-Fi. In your house, you may want to turn off the broadcast and make it so they have to physically type it in. So we have to know what your wireless access point's name is. Again, knowledgeable users can find these SSIDs very quickly because if you're connected to your wireless, every time you send a packet to and from it, it's saying what the SSID is. It's just hidden from Windows. It's hidden from normal Windows and normal Macintosh from displaying it. But if you have software, you can see it very, very quickly. So again, for the A+ exam, disabling SSIDs is a good thing. In the real world, not really effective. The next thing that's really good is network authentication, IEEE 8021X. Each wireless user can actually authenticate using their own credentials, so everybody gets their own usernames and passwords. We use this on wired and wired networks. Okay, so you can use wired and wireless networks. It is the same authentication method used for wireless networks as well, and it is really good. This is something I highly recommend. When you get Network Plus, you can learn all about 802.1x. For the A+ exam, they're not really going to cover it much. Because again, it kind of goes in depth into corporate environments to do this. Most home users are not going to be installing 802.1x in their own systems. Because you got to have an authentication server, and you have to have a supplicant set up, and it's kind of a pain in the butt. But it does provide great security. A pre-shared key. So, most of our access point technologies use what is called a pre-shared key, especially in a small office, home office environment. Your access point and your client are both going to use the same key. It's kind of like our secret password, okay? So if Sarah knows the password and I know the password, we can do our handshake and talk secretly, and no one else will know it. The problem with this is scalability. So, if me and Sarah both know the password, and I fire Sarah from the company, I now need to change the password, which I have to change on both all the clients and the server, right? Or in the access point. If I have 100 clients, I now need to go through 100 machines and change that password. That's kind of a pain in the butt, right? That's where 802.1x comes in, because Sarah has her own password. And so if she gets fired, we just take away her password, right? All users have to know the same key to connect to the network. At your house, this is what you're using. You have one password for all your laptops and your access point to use, okay? So, the 3 ways that we do encryption on our networks. The first one is wired equivalent privacy. It was developed as part of the original wireless standard. It was claimed to be as secure as wired networks. The problem with this is that it only uses a 40-bit key, which, with today's technology, is fairly easy to crack, okay? And even worse, it uses this initialization vector, this 24-bit initialization vector. That initialization vector is sent in clear text. Because there's only 24-bit, that's 2 to the 24th power, there's only a limited number of those combinations. If you sit there and listen to the wireless network and then put it through a mathematical algorithm using a utility, it can churn out and give you the answer to this in about 3 to 5 minutes, okay? There's lots of utilities out there to crack web. It can be done with a brute force attack, meaning I don't really need to know your password, but I can find it out real quick. Access points and clients will use a pre-shared key. They support anywhere from a 64-bit to 128-bit key in the newer systems, but again, it's still relatively weak because of that initialization vector. So, it got replaced, and it got replaced with WPA. WPA is Wi-Fi protected access. It was developed to replace WEP and fix the security weaknesses. So we talked about the fact that it had that 24-bit weak key. So what they did was they said, hey, 24 is not good, let's double it. Now we're going to use a 48-bit key. The problem is 48 bits with today's technology is still too little. This takes about 10 to 15 minutes to crack. So we went from 3 to 5 to 10 to 15, that's still not enough, right? So you don't want to use Wi-Fi protected access for WPA. It uses a thing called the message integrity check, which makes sure that the data wasn't changed in transmission, which is a good thing. But again, that weak key is not good for us. It also had enterprise mode, where we can actually have the users authenticate before exchanging their keys, and the keys between our client and our access point were temporary to make it so we didn't have all that same pre-shared key going on. But again, with that 48-bit initialization vector is too easy to crack. You don't want to use it. So WEP is bad, WPA is bad. So what is good? WPA2. WPA2 is implemented inside 802.11i. You don't need to know that for this test. That's for Network Plus. But you do want to know that it uses CCMP, which is Counter Mode Cipher Block Chaining Message Authentication Code Protocol. If you recognize CCMP on the test, all you need to know is CCMP equals WEP Thorazine WPA2. The answer will be WPA2 if you see that, okay? It uses AES for the encryption, which is an awesome encryption standard. It's what the government uses for top secret communications. It uses a 128-bit key or above, very, very secure algorithm, and it supports enterprise mode for central user authentication or personal mode using a pre-shared key. At your house, you should be using WPA2 with a pre-shared key. In the business, you should be using WPA2 with enterprise mode, where everybody has their own individual username and password. For the A+ exam, they don't expect you to know how to do enterprise mode. They expect you to know how to do personal mode. And we'll actually play with that in our lab. We'll set up an access point, have you guys configure it with WPA2 with a good strong password and connecting some devices to it to make sure you guys have that hands-on experience. Again, most of you have already done this before in your homes because you're using wireless at home, right? But we'll make sure we go through it and show you all the ways. Per A+, we want to secure this by doing this, putting on MAC filtering, by disabling the broadcast, by setting up WPA2. All those good things to give us security. So, which network gives you the best and highest level of protection in a wireless network? Is it WEP, WPA, WPA2, or HTTPS? WPA2, right? It has wireless protected access 2. That is the newest, that is the latest version, and it is still unbreakable as of today in February 2016. The only way they're going to break into your WPA2 connection at this point is they're going to break your password through brute force or password guessing using a dictionary attack. If you have a good strong password, they cannot break into WPA2 as of today. And that could change tomorrow. Hackers are always working on it. But as of today, they still haven't figured that out yet.